Okay, so this first one. What is kind of what is the big piece that I'm doing here?
Product.
7x cubed times e to the 2x. As soon as I say the word times, I know I have product rule. So this is the first, and this is the second. Is the first a basic?
Yes.
Yes, 7x cubed, that's fine. Is the second a basic?
No.
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 So this one's going to also have chain rule. So I'm going to have chain rule here. This one is a very, to me, this should be a fairly straightforward one for a test. This is not complicated, there are no fractions, and it's easy, so we'll get back to that. What about this one?
The chain rule?
Could be the chain rule. You could say this is ln of x to the 7/2, and so that would be a chain rule. Or you could rewrite it, and so I can write this equal sign going down like this. This is where I'm flagging things on assignments where you're writing equal signs for things that are not technically equal. This is equal. If I bring that 7/2 down in front, now is this a basic? Yeah. So I vote for always doing that if you can. What about this one? Basic? Yes. Basic? Did I write that down right? No. Is that a basic?
Yeah.
It is. It's a b to the x. So remember that b to the x goes to b to the x ln b. It's similar to e to the x, but not quite. It's got an extra little factor. Yes?
This may sound dumb, but
Probably not.
let's say you have ln to the x cubed plus, and it's in parentheses, so you know it's ln to everything within the parentheses, and it's ln to the x cubed plus like another variable cubed. Could you still bring the cubed out of both of them? I was just curious.
Because, so what he's asking is if you had this, let's call it y cubed. I could do that. Can I combine those cubes? No. Because this right here is not equal to this. They're not the same thing. So if you had this, ln of x plus y quantity cubed, if it's x plus y quantity cubed, that 3 can come down in front.
Right, okay.
But this one cannot because there are a bunch of middle terms in there that you don't have. So this is not equal to this.
You know, if I'd have just wrote it down, I saw how dumb that was.
Well, not really.
I think I would have. I think I would have wrote it
Okay.
down like that.
All right. I believe you. Okay. All right. So is this a basic? Yes. Is this a basic? Yes, it is. Is this a basic? Yes, same thing. It's that correction factor. We know that ln x goes to 1 over x. This is base e. Log base anything else, in this case 2, will go to the same 1 over x times 1 over ln 2, which is its correction factor. This correction factor, whatever the base is what goes in there. So basic, everything's basic. Okay. So what about this one?
Definitely not basic.
Yeah, it's definitely not basic, right? So what do I need to use for this one?
Use product rule.
Product rule, right there. X times ln. So definitely a product rule. So this is the first, and that is the second. Is the first a basic?
Yeah.
Yes. Is the second a basic? No. It's ln of. So this one is again a chain rule. Okay, that one is again a chain rule because it's ln of. All right, what about number 5? Quotient. That's one way. So if I do bottom times derivative of the top, what's derivative of the top? 0. So that's a clue. There's another way to do this one. You could rewrite this one. So if I were to rewrite it and just bring this up, now what is it? Now it's, what is it now? Yeah, I've got a to the, so if I have to the, that means that I've got probably some sort of chain rule. This is the inside raised to the -4. So this would be power and chain. This one is also power and chain, right? Because in the denominator, the derivative of the top is 0, but what's the derivative of the bottom? Is this a basic? No. That's the inside and that's the outside. So this one also has power and chain. So whether or not you do a quotient rule here, because I'm inclined to do this. I'm inclined to rewrite this one, because when I rewrite it, then I don't have any quotient or quotient or product rule. I just have the power and the chain rule. So if this is a single number, that's, I think, an easier way to go. They will both work, as long as you are careful and remember that the derivative of the top is 0. That's the important piece. What about this one? Quotient. It's exactly the same. When I rewrite this one, so this one I'm seeing quotient. If I attempted to rewrite this one, I would get this. And now I have a product rule. Is that any easier with negative exponents? I actually think this way's harder. So the difference between these two, that's a number. So when I rewrite it, I don't have product rule. This is a variable. So when I rewrite it, I still have product rule. So this, to me, I don't find this to be helpful, so I would not do it that way. This way comes out the same. This way is just kind of a matter of which way you see and which one you want to do. Okay, so of these, let's pick 2 to do. And let's pick the same 2. Let's try and pick the same 2 so that everybody, you can work on them kind of with a partner, and then we'll review them. So which one? I'm inclined to not do this one. This seems easy. I'm inclined not to do this one. That seems easy. 4 would be good. Let's do 4 and... Let's do
5
4.
and 6 are simple though, it's just quotient rule.
Can we just
Right. Let's do 4 and 5 because 5 relates to another problem I have later on the page. So let's do 4 and 5. Okay, so if you would just work on them yourselves for some time, chat with your neighbor. I would prefer you save the cleaning up step. I would prefer you concentrate on the calculus part, particularly for the... Yeah, try and do the whole thing. And I'm just going to rewrite them a little higher on the board. I'm totally fine with you writing F and label all your pieces, write out the formula, whatever helps you keep on track. Feel free to talk with your neighbor. This is not going to be quiet. this is not all there is, right there. So this is product rule. So, yeah, you mix, write out your product rule. First and through, second, write out. You combine the two pieces back. So yes, otherwise you could multiply it out, but that's. So remember, guys, when you're doing this, if you need to write n prime equals first times derivative of the second plus second times derivative of the first, that is completely fine. Do that. That will help keep you moving along the path until you don't need to write that anymore. That's okay. Yes.
One of the things that gets me with Lynn is, like, I get that the first thing's great, I get the exterior and interior, I get the equation, but like, what messes with me is like right here, like, I don't know why, but like I can never like remember like whether or not I should be putting Lynn of X here,
No,
or should I put just the Lynn?
Neither, because the derivative of the one is 1 over. So that's what those are. And that brings up one more thing I want to say. You can never just write this. That doesn't mean anything. It's kind of like writing this. They both require something inside. So ln 2, ln x, ln 5, ln something. Ln y, something. I actually put that in the clarification box because I saw that a bunch. So just remember, a ln and a square root have to have something with it. All right, how are we doing?
Right now I'm good.
Good. How are you guys doing?
So
Making
I'm not
progress?
simplifying this.
How many people have finished the first one? A few? How many people are working on the second one? Anybody done with the second one? All right, let me give you a little bit more time and then we'll go through them. And if you want to, you can start, if you finish those, go work on some of the other problems that we're not doing, just more practice is good. Or help somebody who looks like maybe they are a little bit stuck. Yes.
This is what I'm talking about. This is like where it gets me. It's like putting something times power.
Why do you have S in that? Yeah, well, I would do top and bottom. And why do you, where's?
What?
What do you?
Hey, what are you, hey, you,
Hey,
hey, you,
hey, hey, what are you doing? All right.
Don't hate me.
Okay. So if you're thinking about doing this one as a product rule, then again, you're going to want to write top, bottom times derivative of the top minus tops times the derivative of the bottom all over the bottom square. Or you can do it as just a chain rule.
I don't know why I was.
I'm gonna have it.
Yes. Yes. And then so 2 times 7. And then just start pulling out whatever's coming. All right, so let's go ahead and take a look at these. I should also say that while you're working, I'm busy posting, so the information page that I couldn't show you and these problems and their solutions are now on Blackboard, and shortly I'll have last semester's test and the quizzes too. Okay, so let's look at this one. So, one of the things you need to be careful with product rule is sometimes you spend a long time doing one derivative and you think you're done. So I really encourage you to write this out so that you can make sure that you have all the pieces. Remember that the derivatives are never in the same piece together. There's this piece, and the derivatives are not together in one piece. So we have first x times derivative of the second. So this is a ln, and it's a chain rule. So the first thing we do is we say the derivative of the outside is the ln. That's the inside. So a ln is 1 over. That's the derivative of the ln, 1 over the inside. Times the derivative of the inside, which would be 2x minus 1. Are we done? No, that's just the first piece. Plus the second, ln x squared minus x times derivative of the first, 1. So now let's clean this up a little bit. I'm thinking maybe factor this one in the bottom as well. You might not have seen that. I wouldn't worry about that on a test, but that's just something that, does everyone see what I did? I just multiplied the numerators. These are really like this. So multiply numerators, multiply denominators, but I thought, I see an x in everything, so I'm going to factor that x out. And then times 1 I don't need to worry about. So altogether, this would just be 2x minus 1 over x minus 1 plus ln x squared minus x. So this is the step that I'm really going to be concentrating on the test. That's where all your points are going to come. This will be fewer points. This is algebra cleanup. This is what I really, and so these first 2 steps are kind of what I really want to see. All right, so let's look at this one. Do you want to do this as a quotient rule, or would you rather do it as just a plain old chain rule? Or do you want to do both? Should we do both? That's good practice. So let's start with quotient rule. I have it written down. The bottom, x squared plus 3 to the 4th, times the derivative of the top, 0. That means that whole term is gone, right? Because we're going to multiply by 0. So minus the top, 5, times the derivative of the bottom. So what is the derivative of the bottom? Is this a basic? Every time you say the derivative of, the first question in your brain or out of your mouth should be, is it a basic? Is this one a basic? No, that's a chain rule. So here's the inside. So it's a power. So we're going to have times 4 x squared plus 3 cubed. Are we done with that derivative? No. And if it helps you to put some squiggles and then come over here and put squiggles under the derivative, that might help you, if you don't see squiggles in both places, you haven't handled all the pieces. That's one way to do it. Divided by the bottom squared. So the 4th squared would be to the 8th. Okay, so let's clean up. Remember how we write things in order. So at this point, we have things that we can multiply out. We're going to multiply all the numbers. So 20 times negative 20 times 2 is negative 40. We write the simplest things first.
What happened with the first term? What did you?
This one, it's times 0, so that one's gone. So minus 20 times that 2. Remember, you can multiply in any order, so we're going to multiply all the numbers up and get 1, negative 40. The next thing, that's the next simplest thing, is the x, and then we're going to write the polynomial, and then this is just the denominator. And then we have this. Right, does everybody see that? So as a final answer, we'll have minus 40x over that whole thing to the 5th. Yes?
When you brought the negative 4 down, you knew that one was negative 5.
No, remember, we're doing it this way first. This is quotient rule, so we're not doing this right now. So this is quotient rule, so the derivative, so this is a power rule of the positive form. Now, let's do it again. Let's do it again if we didn't use quotient rule. So this is just some review of quotient rule. Remember, I would write this down. Quotient rule has a top and a bottom. It's got 2 pieces in the top. So make sure you get all your pieces. So let's look at doing this the other way. Now it's just a chain rule, right? Is there any quotient rule to do? Is there any product rule to do?
Right.
No. So the derivative, 5 times, that carries through. What is the derivative of this one? Negative 4 times this to the negative 5. So I've just rewritten this one by pulling this up into the numerator. When I do power rule, this comes down, and that gets bumped down by 1 times the derivative of the inside. And that's going to work out to be exactly the same thing. I'm missing a parenthesis. Because I'll get negative 20, negative 40x, and then that to the 5th would be in the denominator, so same thing. So the next question I had on is, where does this have a horizontal tangent line?
What? Oh.
Yes, that's the next, if you look down to number 7, where does this have a horizontal tangent line? How do I know what kind of a question that is? Horizontal tangent line. Where gives me what kind of an answer? X. Where is an X answer? Horizontal means what?
0.
Slope is
Whoa.
0, right? Importantly, slope is 0. Tangent line tells you slope is derivative. So putting all this together, it says solve y prime equals 0 for x. That's what that means. So you can pull apart those pieces. So here's my derivative. I've already done that. So I need to set this equal to 0. Do I need to worry about the denominator? Can the denominator ever make this fraction 0? No. The only thing that can make this whole thing 0 is if the numerator is 0. So you can multiply both sides by that if it helps you, and that just gets sucked into the 0. So I get negative 40x equals 0, x equals 0. That is where this has a horizontal tangent line. I can find the slope. I can find the equation of the tangent line at any given point. Okay. But I would like to move on because we're, yes, let's move on. Okay, so let's look at the next couple of problems. So we have an implicit and find the equation of the tangent line. We have a resale of a house where you're basically just finding the derivative and plugging in some numbers. I'm inclined to let you do number 9 on your own. I think that one's going to be more simple. So we have the two. We have implicit and we have related rates. Which one do you want to do first? Implicit? Related rates. Related rates. Let's do related rates because I think we can finish that one, and implicit may have some algebra that if we don't finish it, you can see that on the solutions at home. So let's do that. So number 10 says, suppose a boat, you're going to see boats, you're going to see ladders, triangles are easy. Suppose a boat is being pulled up to a dock. If the distance between the boat and the dock is decreased, so let's just draw a picture. Here's your boat. Here's the dock. Here's the rope. Here's the water. Here's the pulley. Whatever.
I have to draw a stick.
Yeah, we can. All right. Let's try to make an ear. I didn't do a very good job. Okay. So if the distance between the boat and the dock is decreasing, okay, by 3 feet per second. I'm already decreasing. Anytime I hear the word decreasing or rate, I automatically think derivative. So I know I've got a derivative. I just need to see where it's going with that. The distance is decreasing by 3 feet per second. How fast is the rope being pulled in when the boat is 20 feet from the dock? Draw a picture. Assume the rope pulley is attached to the dock at a height of 4 feet. Okay, so let's start. We've got our picture. Let's start labeling some things. Remember, yes?
I found on the homework, especially if you don't find the correct sides for the A and the B.
Yes.
Yeah.
You get the
so-
wrong, right.
yeah.
So let's talk about that, absolutely. So the first thing you need to do is everything that varies stays a variable. Everything that's fixed, you can write the number. So is there anything fixed out of that problem? This is fixed. That 4 feet stays the same. The boat's coming in, so that side is changing, and the rope's pulling in, so that side is changing. So they have to stay variable. So let's label them. Let's call it D for distance and R for rope. I'm going to take it out of that ABC of Pythagorean theorem because sometimes that mixes people up if you get the A's and you label them differently. Okay, so now let's look at what we have. If the distance between the boat and the dock, what letter is that? The distance between the boat and the dock? D, is changing, decreasing by 3 feet. Oh, let's make this a capital D. Yes, I promise you, you want to do that. So we know that dt is 3, right? That distance is changing. Is it positive or negative? Negative, because this distance is getting smaller. So sometimes when the book asks a question, how fast is it decreasing? And you're going to get mathematically a negative answer. But when you say decreasing, that is the negative. So you don't, it would decrease by a positive amount. Sometimes in the back of the book, there's a positive number when your answer is negative because the word decreasing takes care of the negative. Okay, how fast is the rope being pulled in? That's what I'm trying to find. So what I'm trying to find, how fast is the rope being pulled in? So I need to put a variable on that.
DRDT.
DRDT is the rope, and I want to know how fast it's moving. So this is DRDT. And then what else do I know? When the boat is 20 feet from the dock. What letter is that? D. So up here I also know D is 20. Importantly, is D always 20?
No.
No, that's an instant in time. So the important thing about related rates is the first thing we need to do is write kind of everything we know, and then we need to write something that relates the variables, things that are changing, and then DDT. So I would like for you guys to do that. So first write an equation for the variables, and then write your equation for the rates. And this is where you do need to be careful, Pythagorean theorem. There's your right angle. So I would stay away from ABC for your letters just because I think that can confuse. So write how these are connected. That's your variables. And then do the derivative.
Like pretty much like the hard part is just putting in like the equation.
Getting this part right here?
Yeah.
Yeah, so that's why we're practicing. That's exactly right, yes. Are we still taking?
Yeah.
How are we doing for time? Okay. So take a moment, get an equation. If you're stuck on the equation, talk to the person next to you, see if you can work it out together.
So what if you like?
Talk to the person behind you.
Yeah, I am.
The person behind you, that will work
I'm
too.
not sure how she's making this up.
I don't know what letter we gave the distance, the cost variable for. Next we don't have to put it there.
I know it's something to do with A squared B squared. So it's gonna be like, so if we're finding the derivative of that, it's gonna be like 2A.
Well, find the equation first.
You're just fine.
The problem is I'm not sure if the A or the B is. I don't think it matters.
Like just B
I
squared.
think A and B.
You know what, here's the problem. You guys have memorized a formula.
I'm thinking about